Let's solve this problem. They have given that logical address space equal to 4 MB and page size equal to 4 KB. Now they are asking that what is the maximum size of page table entry possible, assuming that we are using single level paging. See, in case if they say that we are using single level paging, you need to understand one point. What do you mean by single level paging? The page table should be placed in a complete page, right? The page table, we should be able to place the page table in a complete page. See, we know that we will divide our process into pages, fine. Now we will place these pages in some random frames of RAM. So we are using non-contiguous allocation. So for that reason, we came up with something called as page table, right? In page table, we will maintain an entry for every page, just indicating the frame number in which this corresponding page is present, right? That is the functionality of page table. Now this page table has to be also placed in a single frame of RAM, you know that. Now in case if we are not able to place the complete frame in a single, in case we are not able to place the complete page table in a single frame of RAM, we go for something called as multi-level paging. There is no other option, right? In case if page table size is larger than the size of page, we should definitely go for multi-level paging. But they have given that we should definitely use single level paging. Now what does it mean? In case if they say that it is they are using single level paging, it means that size of page table size should definitely be less than or equal to, okay, it can be either less than or it can be equal to the size of frame, right? This should definitely be true. In case if this is not true, we can't use single level paging, right? We will need to lead to multi level paging, but they have given that we should be using single level paging. Now let's calculate it. See, they have given that page table size is less than or equal to frame size, right? Now let's write what the data which we know. If page size equal to 4 KB, then frame size will also be equal to 4 KB, right? Frame size will also be equal to 4 KB, that is fine. They have given that logical address space equal to 4 MB. Again, I am assuming that it is a byte addressable system, right? So they have given that logical address space equal to 4 MB. So in case if I convert this into bytes, 2 square into 2 power 20 bytes, which is nothing but 2 power 22 bytes. Similarly, page size 2 square into 2 power 10 bytes, which is nothing but 2 power 12 bytes. Fine. So we have in logical address, we will have two fields. One is page number, another one is page offset. Since they have given that page size equal to 2 power 12 bytes, page offset field will have 12 bits. Also, they have given that the total size of logical address is 22 bits, right? In case if it is 2 power 22 bytes, then logical address size is nothing but 22 bits. So 22 minus 12 is nothing but 10. So page number field will have 10 bits, right? Page number field will have 10 bits. So what we can do is this page table size can be written as number of pages into page table size can be written as number of page table entries into size of a single entry, right? Size of a single page table entry, which should be less than or equal to frame size, right? It should be less than or equal to frame size. Now number of page table entries will be equal to number of pages, right? It will always be true. So we know that we have a total of 2 power 10 pages. So I am going to write the number of page table entries as 2 power 10. Why am I doing this? Because number of page table entries is equal to number of pages into size of a single page table entry. Have they given this? See, they have not given. That is what they are asking, right? They are asking what is the maximum size of page table entry. So we don't know this, okay? Let me name this as E. Okay, I'm just naming this as E because I don't need to write this again and again. So I'm just going to write this as E, which is less than or equal to frame size. They have given frame size as 2 power 12 bytes, right? It is nothing but 2 power 12 bytes. So E is less than or equal to, I am bringing this 2 power 10 down, okay. So it is 2 power 12 divided by 2 power 10. This bytes will remain, right? This bytes will remain, this 2 power 10 is coming down. So 2 power 12 divided by 2 power 10 is nothing but 2 square, right? So E, which means E is nothing but size of a single page table entry, should be less than or equal to 2 square bytes, right? Which means E should be less than or equal to 4 bytes. See, what does it mean? The size of a single page table entry should be less than or equal to 4 bytes. Okay, see, now what will happen in case if I increase the size of page table entry above 4 bytes? In case if size of page table entry increases, what will happen? Size of page table will also increase, right? In case if I increase the size of page table entry, size of the page table will also increase. Now in case if size of page table increases, what will happen is the total size of page table will become larger than the size of the page, right? Now in case if the total size of page table becomes larger than the size of the page, we should definitely go for multi-level paging, right? Which is actually contradicting our question. They have given that we should use single level paging. So size of page table entry should be less than or equal to 4 bytes. Now the question they have asked is, what is the maximum size of the page table entry possible? The maximum size of the page table entry possible is nothing but 4 bytes. Assuming that we should definitely use single level paging, okay? In case if you want to use single level paging, the maximum size of page table entry possible is 4 bytes. So answer for this question is 4 bytes.